Welcome back to the lecture series. We'll continue off with the previous one. Earlier, we discussed about the introduction to mechatronic systems, and we also saw different applications, right? So, in this one, we'll discuss about what are the sensors and actuators. We'll discuss more about what are the difference between sensors and a transducer, and then we'll discuss about what are the classifications of a sensor, and then further we'll discuss about what are the characteristics of a sensor. So, mechatronic system, it can be briefly classified into three different parts, as in conventional mechatronic system, micromechatronic systems, and nanomechatronic systems. So, we can classify, if you're able to see the mouse over here, we can classify this portion as classical mechatronic systems. So, this part to the right, we'll call it as quantum mechatronic systems or nanomechatronic systems. We'll discuss why. So, initially we have conventional mechatronic systems and micromechatronic systems. These two actually work based on classical physics. Micromechatronic systems actually it involves both the classical physics, and if it goes beyond, if it is like miniature size, and if it is going beyond a certain point of value, it will involve a lot of quantum mechanics as well. See, for example, like the quantum tunneling on all of these sort of principles or mechanics will start to seep in into the micromechatronic systems as in MEMS devices as well. So, conventional mechatronic systems, it uses the fundamental theories like classical mechanics, electromagnetics, and so on. So, that is what we have like in the meso size or the mega size mechatronic systems. So, all of these will behave with the classical physics that we have already studied so far. So, micromechatronics, it is it started as from a lecture from Richard Feynman, saying that there is more room when you go below, and that is when you go beyond the certain value, as in when you go in the microscopic world, the actual physics sort of changes. So it initially it involves the classical mechanics when it is in the like uh, initial stages of micro mechatronic systems. When it goes beyond that, the physics that involves in the classical or the bigger sizes changes. Say, for example, if you want to make a motor, if you want to have an actuator, and the actuator has to work, I mean, in order to actuate that, we need something, right? So we need a motor. So in, let's say, like in the mega size scale or like meso size scale, what sort of motor will you use, or what sort of mechanism will you use to run your motor? You will use electromagnetic principle, right? Yes. So that is what you will use in conventional mechatronic systems. But when you go to micromechatronic systems, the electromagnetic principle that we use for our like DC AC motors will not be as powerful compared to electrostatic principle. So electrostatic principle holds the upper hand in mechatronic systems there. So we will be better off choosing electrostatic based actuating system compared to like the conventional mechatronic systems, or even SMAs can be used here as well compared to the conventional ones. So the physics changes, and because of that, the structures, shapes, and its limitations also varies in mechatronic systems. And the surface forces and microscale effects, all of these will come into a bigger picture when we are going beyond towards the micro scale. So when we go to the nanomechatronic systems, here the nanoelectronics, nanoelectromechanics will come into play, and quantum theory will be of predominant use here, because quantum theory will be the one that will be guiding the working principle of these nanomechatronic systems. Okay, we'll move on to the sensors. So initially you would have studied, okay, before moving on to sensors, we'll start with transducer first. What is a transducer? Transducers are devices which convert an input from one form of energy to another form. As in, you give one form of energy, let's take for example, let's say thermal energy. We are giving it some heat. We are producing some heat. This transducer as a device, let's say like heat will be the input part, a transducer will be the, let's say like the process or that sort of middle block. So the output that should be there should not be heat. It has to be transformed into a different one. Let's say elongation or a mechanical change. or mechanical elongation. So can you come up with an example like that? Let's say there is heat involved. Let's say a thermometer. Thermometer is a sensor, but it's also a transducer, right? So transducer is nothing but it converts one form of energy to another form. It does not have to be exactly like 1:1, or it has to have a direct relationship with the input and output. It doesn't just convert one form of energy to another. There can be losses. There can be. It does not have to be like 1:1, or it does not have to be like formula based. So just for an example, let's take thermometer as an example. So in thermometer, we have the temperature change. The temperature change, what it does is it changes it raises the melting point of it raises the temperature of the mercury, and because there was a capillary tube, the mercury in the tube rises. So, thus, we understand that there is a temperature change. And if you have a calibrated scale, we can use that to identify the temperature. So, without the calibrating scale, it just gives us the change, that just lets us know that there is a change in temperature. Okay, we'll move to the sensors now. So, sensors are devices which produce a proportional output signal. So, when exposed to a physical phenomenon, actually, when exposed to a phenomenon of that particular sensor's characteristic. Let's say, um, so whenever there is a change, the physical phenomenon of interest of that particular sensor, the sensor should give an output signal that is corresponding to that or proportional to that initial input value, the physical phenomenon or whatever it is. It can also be change in the chemical value as well. Whenever there is a change in the chemistry, as in, let's say, like whenever there is a change in the pH value, or acidity or alkalinity, or the amount of replaceable hydrogen in that particular system, atmosphere, or whatever it is. So what happens is whenever there is that particular chemical change, the pH value changes, there should be a corresponding output signal. Say for example in litmus paper, what happens whenever there is a change in this, the changes, the color's value changes. So based on the, let's say, like the RGB value, or let's say the hue of that particular shade of that particular color changes. So with that we can identify what range of pH scale it lies in. All right. So I'll repeat the sensors definition again. Sensors are devices which produce a proportional output signal to the exposed physical phenomenon. So here we have a list of sensors that I have put here. So we have the thermistor. The thermistor changes. It is used to identify the uh, temperature change. So it is typically a resistor which changes its resistance based on the temperature change. That's as simple as it. Then we have IR sensor. IR sensor, what does IR stand for? Infrared. So infrared, what it does is it sends the infrared light, and when it is reflected back, I mean, so we have two types. One is transmissive type, or another is reflective type. So what simply happens is, let's say you play catch with another person. You're throwing the ball and the other person is catching. Uh, he has to throw it back to you, right? So you do not know where the person exactly is, and he might not know where you are. So you just close your eyes and just throw. When that particular person is able to catch your ball, or just, let's say, the ball sticks to him when it is near him, so he's able to catch the ball and return to you, you can understand how far the ball has traveled and where the person is. So with that, we can you can identify how distant the person is, or the obstacle or the object of interest is. So with that, you can able to understand this ball that is traveling to and fro, right? So that ball is nothing but, in this case, says IR beam or IR waves. So you can use laser, you can use like ultrasonic. So that brings us to the next one, ultrasonic. So it senses ultrasonic sound, and this sound bounces back from the obstacle and gets back to the receiver with the time of flight, how long it has traveled, and it has taken reached back. So with that, we can find out how far the obstacle is. So what is ultrasonic? Ultrasonic is nothing but it is a sound that is beyond the human hearing range. So what is human hearing range? 20 to 20,000 decibels. Yes. So if it is below 20 decibel, then it is called infrasonic sensor, infrasonic sound. If it is higher than 20,000 decibel, then it is called ultrasonic. All right. Then we have gyroscope, accelerometer, rain sensor, moisture, the soil moisture. You can pin it in. So if you are interested in gardening, you can have like the rain sensor and soil moisture sensor. You can plug it in, put it in your microcontroller of choice, and you can get a program anywhere online, or you can just use your what is it, Gamma or sorry, Gemini or ChatGPT or whatever it is to get a code, and then plug it in using Arduino, Uno, or Arduino IDE or whatever it is. It will be easier for you to identify what is the soil, and it is very easy to make your DIY kit where your let's say with the amount of soil moisture for your plant that can be calculated for that particular plant, and it can water itself. You can have a like water, let's say like a tank or water bottle, which will be the like sump or tank for your particular project, and then you can have a motor and a soil moisture sensor. With the amount of soil moisture required for that plant, when it is going below that, water can be your motor can be turned on and it can water it, and when it reaches the saturation value or the value that you are interested in or you are set, it has to stop. So this can be a very good and interesting and useful project for you to start off. There are high chances that it is very easy to get it in the first try itself. So that will be a very interesting project, and you can use ultrasonic sensor to measure distance from your let's say from your sensor and obstacle or whatever it is. You can use that on your car, and like you can have a remote car, and you can connect your ultrasonic sensor to your remote car, and whenever it is closer to hitting an object, maybe you can give it a command to like take a right or take a left or whatever it is. I mean, depending on your convenience or your path plan. So classification of a sensor and transducer. So we can briefly, I mean, classify it as active sensor, passive sensor, analog sensor, and digital sensor. What is an active sensor? Active sensor is nothing but it requires, these are sensors that require power to be given. That is, let's say, so you have some devices which need to be plugged into your wall socket or a battery. It requires battery, and there are some devices that do not require I mean like connect to your wall socket or battery. So these active sensors, these do not require a battery or a wall socket, so they produce their own output, and this output is the corresponding thing that is coming from the sensed physical phenomenon. So active sensors can be called as self-generating transducer. They are actively generating their own output. Passive sensors, these work when you give it an external power source. Example like strain gauge, resistance thermometers, and so on, where you give the power or the supply. Let's say like you are giving it a current, right? And there is this particular, as we discussed earlier, the thermometer that I mean the temperature measuring device that measures based on resistance states. Comment below what was that particular sensor's name. So with the there is a hint given here called as a resistance thermometer, but earlier we discussed the particular term for that. Okay, so what happens here is because of the change in the temperature, the resistance value changes, and when there is the resistance value changes, what happens is when we have the electric circuit going on, the supply is given from outside, right? So that particular supply value will change. So by that way, we will be able to sense the change in the uh, let's say like the thing of interest. In this case, the temperature change, maybe like change the light intensity, and all of these things can be. There are differences for that as well. Then we have analog sensor, which gives continuous signal. So analog sensors you would have seen like previously you would have used like ammeters and so on, which have dials, right? So it works basically on the like physical phenomenon or mechanical